So let me just do the official welcome to these streaming stories that are focusing on the relationship between crypto, fintech, and stream processing. And this is a topic that we wanted to cover for a really long time, given that we already have several users in the crypto space who have been trying RisingWave, and we figured out that there is really a match there. So I'm very happy to welcome three practitioners who are building their real-time data infra in the crypto space, using products such as RisingWave, but also other modern systems. So let me welcome Yaroslav Krchenko from Goldsky, who I wanted to invite a long time ago to Streaming Stories. Oding Wang from Alchemy, and James Corbett from help me, James.
Superchain
Network. Okay, so thank you all for being with us here today. So just before we start, just very few housekeeping rules. We will have some framework for discussions. Yingjun and I will be co-moderating this panel. If you want to ask a question, there is a Q&A button down there. There is also chat if you want to interact with us, if there are a technical issue or anything. Yeah, just ping me if there is any problem with Zoom or anything. So let's officially start. And we haven't really talked how we're going to go about this, who want to start first, but let me just give you some time to do your spiel at the beginning on tell a little bit about the company you're working at, what it is that you're working on, who are your customers, what are the typical use cases, and how stream processing fits into it. So,
well, there are so many questions, but
I know, but
there are so many questions, right? But we can start with some. Yeah. Anyways, yeah.
So who want to go
who
first?
Want to go first? Yeah.
Alphabetic or no?
I guess I can go first.
Sure. Unmuted himself. So
let's go reverse alphabetical. Yeah, so I'm Yaroslav. I work with a company called Goldsky, and we are a blockchain data infrastructure company, right? So we provide blockchain data sets to our customers. It's interesting that when you think about data infrastructure, you might hear things like in analytical workloads a lot, but we actually, what we noticed, a lot of our customers build applications with blockchain data. So they are blockchain developers, deploying their smart contract, deploying their decentralized applications, and they want to get data out of blockchain, but that's hard. And we noticed that if you have a very reliable way to get data out of blockchain, you can build very interesting applications on top of it. So the way people use Goldsky is they mirror data from blockchain, maybe apply some transformations, and then write it to their database of choice. Something like Postgres, a ClickHouse, Elasticsearch, Kafka S3. We support a lot of those connectors. And then you can build a real experience like a web app, website that users use. And so if you think about this kind of end-to-end, if Goldsky goes down, then all this web applications, they stop receiving fresh data. So that's very, very critical for us to have high uptime and low latency. And that's the reason why we chose to go with streaming. So since we started, we used Redpanda and Apache Flink as two technologies that we combine to kind of represent all those blockchain data sets as essential Redpanda topics, and then use Flink and Flink SQL to process the data and shape it in the right way and kind of ship it to the customers. And in our case, customers interact with Flink SQL directly if they want, and deploy those pipelines to move the data from blockchain to database of their choice.
Thanks, Yaroslav. Who's next?
I can go next. So I'm Odin, and I focus on data infrastructure and Alchemy. And Alchemy is the developer platform company for Web3. We provide a range of tools and services for people to build on top of blockchain. That include the core node APIs for people to do like read and write access to the nodes, but also higher level APIs and account abstraction for people to easily interact with the decentralized apps, transaction related like transaction simulation, and like for people to monitor their transaction status and the debugging tools. And basically like we are focused to allow people to easily build on top of blockchain. We believe this is critical for the success of Web3 because right now we are still very, very early in the space and there are a lot to be built, but blockchain is actually not that easy to use, and we are working to lower the end, like the bar for building. So although we are not super focused on streaming like holistically as our business, like you can see that eventually what we do is to deliver the data from the node to the developers in some way, like either it's an API call or something else. And internally we utilize the stream processing technologies. So maybe to talk a little bit more for me, like I focus on data infrastructure, not just on the streaming side. So I have also been working on our batch processing stuff. And interestingly, there is a big overlap between the two. To be honest, streaming is something that's relatively new to me. Like for the most part of my career, I have been focusing on batch processing related stuff. Like before Alchemy, I was working for Robinhood, building experimentation platforms where we primarily do batch-based like analytical workload. Yeah, I'll stop here.
Yeah, we'll definitely talk more about this. Was it like an evolution from batch to streaming in like all of your 3 cases, or whether it was like streaming first from the start? So we'll get to that. James, your turn.
Yes, thanks very much. So yeah, I guess we're a little bit different to the other kind of co-panelists in that we're building a decentralized protocol. So I'm from Superchain. We're building the open index protocol. So kind of similarly that, we really feel that user experience and the usability of a lot of products in crypto is kind of awful. We see this as a blocker to growth. And basically, we've been building a solution to that. So our customers are usually like either fintech, TradFi, or dApps that need data from different decentralized finance. And basically trust and low latency are requirements from our users to get great trading experiences. In terms of like streaming in real time, basically I've got a history of building indexes across crypto, been in crypto like 8 years, and we kind of wanted to build once and for all the last one. Yeah, we tried lots of different things in the past, batch stuff, streaming stuff, etc. And we ended up building our own stack to do streaming from scratch. So it's quite a different approach to you guys, but it's serving as well. It takes us a lot longer to get to where we got to, but now we kind of got good performance and stuff. So yeah, that's us.
Cool. I think you guys actually have quite different data infra, right? And it seems that's okay. I mean, some of you guys, probably just started with, stream processing, but some probably started with batch, right? So the question here that I have is that do you really care about the real-time data? Or probably, your customers, do your customers care about the real time? Like, and if they care about the real time, why? What's the main, right? Whether they are doing some, transactions, or whether they want to do some like tradings, or they want to do some monitorings, right? Basically, why they need real time.
My answer is probably the easiest one, is that people actually build web applications on top of this data sets, right? So many of our customers just show this data on the website, right? So if it's not real time, it's going to be delayed by minutes, hours, however it takes to run that batch job, right? So it's amazing to see those types of experiences where block was just created and literally within like a couple seconds you see it been reflected in the customer's website, right? And that what allows people to actually leverage us to build those applications, because if you don't have that real timeness, the number of use cases you can really apply this data set to is very small, right? It's mostly analytical. So I guess if you need anything operational, anything you put in front of the users, it has to be real time. Otherwise, it's not going to be very useful.
So in your case, your real time means what? Means second level or minutes or
means
hours?
Seconds.
Definitely not hours, right?
Seconds.
Okay. Seconds, like 10 seconds or 5 seconds or
like under 10 seconds. I think that's like a good enough latency latency for anything that's operational. That's not like high critical. We're not talking about trading or anything like that, or like IoT. No, it's reasonable when you're building like a web application, I think.
Yep.
Cool. Yeah, totally agree with Slava here. Like it's a similar for us in that our users build applications that use like end users, consumers may need, and it's actually pretty critical for people to see the latest data. But I also agree that when we talk about like real time, it's not necessarily sub-second level real time. Primarily because when we work with blockchain data, there is some limit in the throughput of the blockchain node, like how fast or how often a new block can be produced. And for some of the popular blockchains, for example, Ethereum, the like block is typically produced every 12 seconds, and that is kind of the upstream limit that we are working with. It means like even if our pipeline is super quick, we are still going to be limited by that.
So I guess I got slightly different opinion to you guys, just from the perspective of what our customers want. So yeah, for us, real time actually means less than 10 milliseconds. So we have to go from the block to outputting data to our customers within that time frame. Otherwise, yeah, it's kind of a problem. Now, yeah, I agree with you that in terms of like, the block time being, very high, it's just more for in terms of the feel and the experience to get it down to that kind of level really helps our customers. I think the thing to highlight here, and this is different to like, a normal industry, crypto has this concept of like block reorganization, which is obviously a pain point for everybody. RPC providers or Gold Sky, like you guys, I'm sure, have to deal with this. So, and that's been our key to our problem, and obviously building our streaming stack from the ground up ourselves. That has let us deal with block reorganization natively. Now, with our financially focused customers, that's become really important, where they can basically see that truth as immediately as possible within this 10 millisecond boundary. So.
So, Odin, actually, you mentioned that your companies were actually started with batch, right? So it means that does it mean that real time is not that critical to your company or to your customers?
Yeah, maybe I should clarify a little bit on that. It's not that my company started on batch. It's more that my journey in this company started more on batch, where I was focusing more on our batch related stack, like internal data, BI analytics, and also some batch pipelines for moving data around. And I would say since very beginning, we focused on like real timeness or like delivering most fresh data to the customers. So that was a requirement that never changed.
So in your case, we also set a 10-second level, right?
Yeah, but like to James's point, although like there might be some kind of 10 seconds idea where we are working with like the upstream limitation, we definitely want to deliver the data to the customers the hand as soon as the data becomes available or whenever reorg happens. So I guess like there is the SLA or like limit, like a kind of worst case portion of this, and there are more like what we want to achieve part.
Okay, so actually, I have a follow-up question to you guys. Like, yeah, I believe that's okay. A lot of companies nowadays were using, like, say, stream technologies, right? Stream processing technologies, but definitely some companies started with batch processing, and they probably use Spark or probably use Snowflake, Redshift, or whatever, right? And can we just leverage those systems? Because, well, I mean, look, if I use Databricks, if let's say Snowflake, right? Well, I can probably add, let's say, some orchestration tools and do the recompilation every 10 seconds. I'm not sure whether it's practical, but well, we can do recompilation, right? Can we do that? Will it make the data stack simpler, right?
Sorry, I don't quite understand the question.
So look, I mean, can we just use, let's say, a data warehouse like Snowflake, and we ingest the data from your data source to directly into data warehouse, and then we do computation there. We basically do recompilation using some orchestration tools. We can do recompilation every, let's say, 10 seconds. Can we do that? I'll think about the most. Yeah.
Yeah.
Go ahead.
I can answer some of that. So again, this comes from mostly thinking about latency, right? When you think like streaming versus batch, what people think first of all is latency, and that's a good one to cover, but I don't think it's the only one, right? We just had an interesting discussion, like on LinkedIn, like yesterday, about for example, upserting data or retracting or correcting data, right? So streaming gives you a primitive, like a changelog stream, right? Where you can model updates, inserts, deletes as different records, right? And then whenever you get, for example, late driving data, and reworks can be modeled as late driving data. If you think about it, you can maybe emit those and correct data from, like 3 months ago or something. Not the case of reorg, but like conceptually, if you leverage streaming, the ability to update, upsert, retract historical data becomes a bit more easier, I feel like, because whenever you do batch, you mostly operate on a single partition, right? Like daily partition, hourly partition. It's very hard for you to go back and like correct data from 3 days ago when you use batch technology. So that's something I also like to mention, right? It's not just about latency. Sometimes streaming gives you better computational primitives, for example, for correcting data. And that definitely helps for us because we just model those block organizations that were already mentioned as, hey, it's just a retraction, right? This transaction was correct before, but now it's not because the correct block is now a different one, right? So we just emit those as retractions, and we can propagate them all the way to a customer's database. Would be very hard to do with batch.
Yeah, it's gonna be pretty challenging with batch, and even if we can do it, the logic probably is more complicated in some sense, and there is gonna be less efficiency because we need to do more like reprocessing. But theoretically, to answer your question of can we replace it with a batch system, assuming the batch system is actually pretty fast and we do not care about cost, which is definitely not the case, we can theoretically build something on the batch system that delivers the data in latency, like maybe 10 seconds is a stretch, but a minute seems more reasonable to me.
Okay, so it means, okay, I mean, if I use, let's say, Spark, you think that Spark will be more expensive compared to stream processing if I want to deliver real-time results, right?
I do not have. Yeah, sorry, go ahead.
Spark is a bit difficult. So it's a very kind of classical kind of enterprise big data tech. So it's like really fast compared to like Hadoop, which is the thing it replaced. But in terms of like using it on the front end for like doing SQL queries and things like that, it's not ideal. I know they're trying to move to streaming and things, and they'll get there eventually. But it's really like for us, like especially as we have to like deploy this to other people's machines as well in the future when we've got like a decentralized network running on hundreds of machines. It really wasn't like an option we could consider. But yeah, although it is easy to use, and SQL in particular in a streaming interface is really useful. It's one of the reasons why we looked at RisingWave in comparison to something like Spark, which is more batchy in nature.
So actually, we just mentioned a pretty interesting question. That is for the cost, right? So when I talk to some data engineers or developers, they will think actually have the impression that, okay, look, stream processing is more expensive than batch, or probably it's way more expensive than batch processing. Some people will claim that. And I'm not sure whether in your case or do you think that stream processing is too expensive, or you think that, okay, look, it is expensive, that's true, but it brings a lot of value. It brings much more value, and people really love to pay for what they get.
I have some very funny anecdotal experience about that, about the cost. So I used to work for a company called Activision, and we had a bunch of data pipelines for Call of Duty games. So pretty good scale if you think about all the telemetry collecting from that. And we had a lot of batch jobs, primarily Spark, but also Hive, some Hadoop MapReduce. And we replaced all of that with a streaming stack on Kafka Streams and Kafka Connect. And we measured how much it cost and, did the comparison. And it turned out that the new system was 90% cheaper than the old one. And it was like, oh, why? Why such a big difference, right? And, partially it was because we were just too lazy to optimize, right? You write this batch job, you run it daily, it keeps running for like months or years without anyone looking and like paying any attention to optimization. It can get expensive eventually. And also if your job runs for like 12 hours and it occasionally fails after 10 hours and you need to redo it again, yeah, guess what? You're still paying to your provider or, paying for resources for those 10 hours that you kind of wasted, right? And now you need to start again. In the streaming context, it's really hard to, keep failing for 10 hours because you will be notified, alerted, pinged, and you'll have to fix it. So in a way, streaming kind of forces you to be lower, like tighter SLA and kind of have this a bit more SRE mentality, right? Thinking about alerting and operations a bit more. Where in batch, it's very easy. It just schedule something, it runs, for hours, maybe occasionally fails, but you don't really spend too much time looking into that. So I think that can be a big differentiator when it comes to cost.
So
oh, sorry, Odin.
Yeah. So when we talk about cost, there is like infrastructure or service cost, and there is also the cost of developing or engineering. Eventually we need to build it. I would say like typically when people think about like stream processing being more expensive, they probably are focused more on the engineering cost. But on the infrastructure side, at least like technically, when streaming jobs are optimized, like when it can maintain the states, the computation that you do are just gonna be the incremental computation that is needed. But for batch processing, typically you need to redo a lot of stuff. But even with this consideration, like there is also the reality where sometimes if you force like the stream processing, like for example, Flink to run some batch workload, it might be like underperforming, or like especially if we do some benchmarking, if Spark is 3 times, 5 times faster, and the workload is actually decent, it might make sense to use a batch native engine to do this.
I'll just agree with both of you guys' points. We chose the trade-off, which was, more difficult development in order to do streaming. And that, that's our opinion. It was more difficult than just doing a batch engine. It's just that batch engines wouldn't meet the requirements that we had. So yeah, just echoing that's the trade-off that I think you do have to make, like at least if you're building something from scratch, is that building streaming managing streaming, managing the state through streams is a really difficult thing to do, as I'm sure the guys at RisingWave well know. So yeah, that's the trade-off we made. Slightly more development costs, and certainly higher development complexity, more testing required, etc. Than just straight off batch process that can just fail or be good.
So the okay, so basically what you guys mentioned was that essentially in terms of when we say cost, well, I mean people probably when people say that stream processing is probably more expensive than batch, and you guys will think that it's more about the development cost, right? So it's not about the infra cost. The infra cost is manageable, right? It's not that pretty high compared to batching system, right?
Yeah, I'd
Okay.
agree with that.
Yeah. So then actually another question here that for stream processing, it's actually long running job, right? So it's actually a long running system, but for batch, bro, it's not the case, right? So for batch, bro, it's like okay, if a system crashes, then I mean it's fine. I mean it's still okay because you can just rerun the query, right? But for stream processing, it means that continuous query processing and probably it can yeah, the system probably cannot. People do not really want to see that I mean, a system just crashes, then I cannot receive any results, right? So in terms of the failure recovery, or in terms of the high availability, do you have any specific requirements like okay, if the system crashes, I want the system to recover from within 10 seconds, or probably within 1 hour, 1 minute, or probably within 10 minutes. Do you have such kind of requirement?
Yeah, in our case, as I mentioned, we power real kind of web applications that users access. So whenever something goes down, it's paramount to just go back to the healthy state as soon as possible, because people are just not going to see fresh data right on their web applications websites. And we just use standard, links, for example, and Redpanda's mechanisms like retries, exponential backoff, like all those things. I don't think this is specific to like blockchain and crypto in any way. It's just like a good practice in general. Have high availability, have those retries in place, and of course, if you use a streaming system like Kafka, Redpanda, the good thing is the data is there. You can always go back to the correct offset, that you committed before, or that you need to resume from. So it's a great model from that perspective. You can always kind of go back, as long as you have retention that's higher than your typical like outage time. Yeah, I guess using all those standard primitives that you find in Kafka, Flink, like retries, they do help. I don't think you need anything extra on top of that. But happy to hear other opinions.
Yeah. Do you want to?
Yeah. So, like we all agree that like failure is undesirable, but indeed like the recovery on the streaming side can be more challenging, especially because of management of states. I would say like at least like in comparison on batch side, although the recovery might be easier, the action to recover is usually much longer. Like it's very unlikely that a batch job fails, like you retry like and finish like within 10 seconds or a few minutes. So I would say like in terms of people's expectations, even when the streaming is harder to recover and it takes some time and potentially breaks the real-time guarantee, it's still a better experience in many cases than doing a batch-based system. However, I do think this is a challenging topic, and there are definitely developments needed to make it easier for people working on streaming to do those like failure recovery.
So let's say that I believe that's true. Any machine can crash, right? So let's say that a machine crashes. Then what's your expectation? Do you expect that it will be recovered within 10 seconds? Where is that okay? Or probably think that it's not tolerable?
So
or you think that even for 1 minute or probably 10 minutes are okay?
we have really tight tolerances. So we run highly available across different data centers in the centralized form right now. So any data center can go down with no interruption to users, which is essential for us. If we lose a whole data center, it does take time to rebuild it, as you might imagine, because we've got like tens of terabytes of data to acquire from somewhere, especially if we need to like resync blockchain nodes. But I mean, the reality is like minor failures, like single services going down, are pretty much like no problem. Like they just come back up, like power cut on one server or something network card goes funky or whatever. We're very, very quick to recover from those common ones. But certainly like the bigger failures could be, very time consuming. I think this is one of the tricks with a decentralized network, is that, as a whole, any single node failure doesn't really affect it, because you already have basically like massive replication in terms of the data. So that's kind of one of our ideas behind Superchain.
Yeah. Cool. So actually, another question that is quite relevant to failure recovery is the dynamic scaling, right, or elasticity. So let's say that, okay, I'm not sure about your workload, but whenever workloads, I mean, when dealing with streaming data, right, the workload can definitely fluctuate, right? Do you really care about? I'm not sure whether in your case, do you think that dynamic scaling is pretty important in your case, or you think that case is fine? I also know that in some companies where you just provision much more resources than needed, so that they can guarantee that they do not need to care too much about the dynamic scaling, right? So yeah. I'm not sure.
I'll
Any
jump
opinion?
in here, because like I think that we've really experienced this in crypto in like a really serious way, where in the bull run, when everybody's all excited about crypto applications, everywhere they're just crashing all over the place. Like, they basically became unusable for periods of time in high trading volumes. Binance Smart Chain has a very high TPS, right? So high transactions per second. And you just saw apps on there like stop, which is, completely unacceptable for the future of finance. So we do actually have like quite spiky workloads as crypto companies. For example, now where the market's not very exciting, there's not many users, there's not many transactions, and that obviously affects like the streaming throughput. So we have to be very careful to like test under conditions that are more representative of like an exciting scenario, rather than the current kind of couple of TPS or whatever, which is almost like not having users. So we don't do dynamic scaling, but we do definitely want to account for very spiky loads of these kinds, and we've done that through kind of trying to keep it as efficient as possible.
Okay.
And just to add something, we also currently don't do dynamic scaling. We really want to for other reasons. But I think what James said is true. I don't think right now, like if you look at all the major chains that are popular across developers, the TPS, right, the amount of data that's coming through it, it's not that high if you compare it to big tech companies. Like you might not realize, but the blockchain data is actually not that large, right? Again, if you compare it to what like Netflix processes per day, it's probably like way lower. all of Ethereum, for example. So using even relatively small deployments of like traditional tools like Spark and Flink and Kafka, I feel like they can absorb that traffic quite well. So even if you see a spike, it's still not that significant. Like it's not like it's 10x, and that pushes your infra quite a bit. So I think it's a bit more predictable, and everybody knows like how many blocks per minute a certain chain creates, and yes, that number can like change eventually, and you might have like more transactions packed in a block or something, but like it's relatively stable, I think, right now.
So yeah, Odin, any opinion?
Yeah, I agree with the others. Particularly for us, we do not really have a lot of dynamic scaling events happening, and a lot of times when we do scaling, it is when we do large backfilling, or where the upstream is controlled by us and the timing is controlled by us, and we are perfectly okay with manual scaling. But I definitely agree that right now we are using Flink, and like the overall dynamic scaling experience is not that great.
Okay, so cool. And then let's talk about something about more technical. So we actually know that there are actually a lot of the stream processing technologies, right? Or streaming technologies like Kafka, Redpanda, like Flink, RisingWave, or whatever, right? And what kind of systems you have already used, or probably you probably previously used, and then now currently use, or probably you are currently evaluating, and what's the pain points and what's the advantage of these systems? Yeah. Cool.
That's probably another hour, right? To go through that.
Yeah, sure. Yeah, go ahead. Yeah.
I can just cover the Redpanda versus Apache Kafka, for example, because that is something that when I mentioned we use Redpanda, people always ask like, oh, how's your experience? Honestly, it is, as you probably know, it is a completely different system, right? It's completely written from scratch in C++. It uses the same Kafka API protocol, right? But it is a very different implementation. So obviously, first thing you think is, well, is it going to be compatible with what I have, right? Will I need to make any changes? And honestly, so far, we used Apache Flink, we used some Golang, Python, consumers and producers. We use different tools, and every time, it just works. So kudos to the team behind. It's, there are no questions about compatibility like whatsoever. Everything just works. Of course, there are like some fairly exotic or new Kafka features that might not be available in Redpanda. That's fine, but like the core technology, we've been running with it for more than a year and fairly happy. And then cost is something we covered, right? So there are all these benchmarks online comparing like Redpanda with Kafka, and we do find that it's cheaper. Mostly because they managed to build a more efficient engine, right? In C++, you do more direct memory management, and you don't have that huge heap size when you compare to like JVM based technologies. So there's definitely something there. Zookeeper, like absence of Zookeeper was something that they've been telling for a while, but that's also not a problem now with modern versions of Kafka. And also the thing that I really like about Redpanda is the fact that it's a single binary, and the binary comes with the actual broker, with the schema registry, with the HTTP proxy, and with the Prometheus endpoint, like all combined together essentially in one executable. So that's also great for local development, staging, QA, where it's very easy, lightweight to spin up, and you kind of have a single container in your SI environment that contains like all of those things that you typically need from a streaming platform. So I think we have a question that I'm happy to answer.
So it's quickly about how you deploy Redpanda.
So right now we use the cloud offering, so it's fully managed, mostly because we are a small team and we want to, someone else to take care of that. So the cloud offering, I think we were very early adopters of the kind of early version, and now V2 is what we use. But I would definitely consider kind of BOIC offering if we were bigger. Right, if I have a bigger team, kind of more infra engineers capable of maybe debugging some of the issues. It's just a question of team size, in my opinion.
And then who's next? Auding?
Yeah, actually, excuse me. What was the original question you were asking?
I mean, I was asking about the streaming technology. Like, okay, what kind of technology do you have used, or probably you're currently using, or probably you're currently evaluating, and what's the advantages and probably potentially the pain points of these systems, right? So yeah, so I mean, you actually mentioned that you can actually come from the dashboard, right? And probably definitely you can also mention some batch systems if you are more familiar with those systems. Yeah.
Yeah. So maybe I can talk a little bit about Apache Flink. Like we are using Flink right now. There are definitely pinpoints in like how we manage it, and but overall, I would say it is currently the framework that can provide the most for us. Like without talking too much about the operational or like complexity in like managing it, the at least like when it comes to the feature or capabilities, it is one that is overall like best. For example, we do a lot of Java-based like data stream API-based applications, and although like using SQL can be easier, like we just find like some of the logic is more reasonable to be expressed in Java. And because of this, we do not really have a lot of alternatives or mainstream alternatives that we can consider. However, I would say like ultimately, I do not really consider like when we think about like a streaming data platform, it doesn't have to be only centered around a single stream processing framework. Like potentially we can leverage multiple frameworks together. For example, like one possibility here is like using RisingWave, and then example, if RisingWave can do really good like query on the serving side, like a very fast query, very efficient queries on the serving side, potentially it can be one of the or part of the pipelines, especially on the end part, like the downstream, like closer to the users, where users tend to interact more with SQL queries, and they might want to have access to a database and serve their like application needs. Right now, we are not using RisingWave, but the idea is that we are not necessarily limited to a single framework like Flink.
So you actually mentioned that you come from the dashboard. Have you ever tried some more batch-oriented systems like Spark streaming, something like that?
I never used the Spark streaming before, and I like didn't really consider Spark itself because the overhead in like using Spark, like especially like a single job, like when you like schedule a job, the overhead of like scheduling is high enough that it's not going to be a real-time experience. However, I did consider some of the more like real-time OLAP systems where it's a kind of real-time OLAP, but like if you do micro batching, potentially the latency is somewhat under control. However, those systems are mostly SQL based, and it's very hard to have also like it's very hard to have like the full like streaming experience where you can also like CDC data to another store. So like although some of those like real-time OLAP systems can potentially solve some of our use cases, it's not going to be a solution that can potentially solve all those issues, like like Flink.
Okay, then all right. Then how about James?
Yeah, I mean,
what's your data stack?
to be honest, yeah, I haven't got as much to add in that. Just that we have evaluated Kafka, Redpanda, etc. And they just weren't fit for our performance characteristics, and also the cost of running them was really high because they're enterprise systems, right? So they're great for companies, great for that kind of thing. But we had a requirement to decentralize, and they're really hard to decentralize. And so yeah, we end up building our own streaming system, which is decentralizable as well. So that obviously carries with it a lot of different problems. So like our problems are much more like, how do you build a streaming system from scratch and make it work in, you know, an easy way for developers? But we did actually look at something like RisingWave, and we do connect to Kafka and all these other things because a lot of our customers, they just want to shove it in a data lake or a streaming thing into their current kind of way of doing things, which is great for them. But yeah, with us, we ended up building something from scratch to do that.
So you mentioned that you build something from scratch. You mean that you build something like Kafka from scratch, or you build something like RisingWave, something like RisingWave from scratch? So what do you mean by building something from scratch?
So basically, our entire platform is like a streaming database designed specifically for blockchain data. So that's been built from scratch in Rust, all the way down to file formats, all the way up to how it connects and the networking and everything else. So it's completely different to anything else on the market, and it's only for crypto data. So we're not like PhD crazy science people, but we were able to constrain the problem in such a way that we could build something very effective. We did destroy quite a few SSDs in the process, but we're there now.
Okay. But you do not really need to rebuild like something like Kafka from scratch, right?
No, exactly, because that would be really hard. Because Kafka's generic, it works for everybody, and that's awesome, right? Like we wish we could use Kafka, make my life so much easier. But we had to build something specifically for blockchains and blockchain data that you could say for us fits that use case where Kafka would have sat. But the reality is it's nowhere near as comprehensive as Kafka, because Kafka has to do everything the world could want to do with streaming data. We only do what we need to do for crypto data within our system, which is a very narrow use case in comparison.
But can you just leverage the existing system to build a platform? Because definitely there are some specialized formats, right? But probably you can just do some hacking and reuse some of the existing data stack, right? Can you do that?
We did try.
It's not quite efficient. Yeah, go ahead.
We did try. Over time, we just iterated. We did like well over a year of R&D, and we ended up just gradually stripping out everything until it was pretty much all custom. So it's unfortunate, but it's just the problem is if you want to get into like the real optimization games on hardware, you have to do it yourself, because there's no one has done this. Like so like if you take things like how do you access like SSDs and be aware of access patterns on SSDs and the latency that you're going to incur based on those access patterns. Like you can't just like pull a library and start using it with its however it's dealing with files. You have to deal with that yourself. So suddenly you get into all this hell of like how do you build a database or something like this. It's really difficult. So yeah, with those we've managed to make those assumptions that we could make because it's blockchain data. Like for example, like the node is our source of truth, right? So we don't have to like necessarily worry too much if our entire platform gets deleted. It can like restore itself from the blockchain node and start again from scratch, which is great. So there was the nice things like that. Whereas Kafka, if you run that, it's going to replicate itself. You can, set fire to the data center and it's going to be fine. At least that's my experience of using it is absolutely bulletproof. So it's just a very different target set of use cases. You have to remember as well, like Kafka's focus on one company replicating its data like within one scope or maybe a couple of data centers, whereas we're focused on like distributing to all like thousands and thousands of validators. And there's a completely different game in terms of like how you design a system to do that, because you've got replication by default. So it's just a different set of paradigms that we're operating
in. Very cool to say planet scale.
Yeah.
Yeah, I'll take that.
Yeah, cool. So in your system, do you provide a SQL interface, or you provide some other interface?
So we kind of did bolt a SQL interface on. It's not quite what we wanted because it doesn't stream. So we use like some off-the-shelf SQL stuff, Data Fusion and Polars. Yeah, Polars. They were really cool and we really liked them. But they they're obviously non-streaming. So that's actually why we started looking into RisingWave. So we could say to our customer, like, hey, you want streaming, deploy this thing. Sorry, you want SQL, deploy this thing. It's streaming, it'll work. The latency overhead is like, it's something, but it's pretty reasonable compared to any of these other systems without deploying something like Flink or whatever. Or they'll have their own like trading systems and they're like completely different. They're like time series type databases. Yeah.
Mm-hmm. Okay, cool. So yeah, we actually discussed a lot about the existing systems, right? But if you so what's the pain points of your data stack? Or you think that if I mean, I definitely believe that yeah, your data stack is running smoothly, right? But well, let's say that if you want to improve one thing, then what the kind of things you want to improve?
I can start. I think this classic kind of big data frameworks like Flink and Spark, they were designed many years ago. They're great for what they do, but right now, with the decentralization, especially, right, you kind of see this need to deploy many small things, right? Not like one large job that processes all your data and deployed on like hundreds of machines. You actually want hundreds of machines deployed with like small individual jobs. Maybe it's IoT, maybe doing some, I don't know, something else. But anything that's like customer driven, for example, right? When customers create pipelines or create workloads, you want it to be very efficient, right? You want it to be very kind of low footprint when it comes to resources, as efficient as possible, right? And Flink, for example, or Spark, they just require you to, by default, allocate, several gigabytes of memory, a couple of CPU cores just to run. Even if they process, 10 records a minute, you still need like, I don't know, 4 gigs of RAM to just start Flink up. And so that's why, for example, I'm really, excited about the whole Rust ecosystem. And James mentioned Data Fusion. The whole Arrow ecosystem is amazing with Data Fusion, Ballista, Arrow Flight, like all of that. You get like a crazy efficient in-memory data format. You get Rust, which is amazing for performance reasons. You get Data Fusion, which is essentially like build your own SQL engine from building blocks, right? So and that you can already see people using that to build streaming systems. RisingWave I know is based on Rust, right? But there's also companies, for example, like Arroyo, which is an attempt to build a Flink-like system, but using Rust and Data Fusion and all of that. So I totally understand like why Flink is great at what it does, but I'm also really excited about kind of the next iteration of systems that might be a bit more efficient and that will allow essentially us to deploy like many of those workloads very easily.
Cool. And then Odin, your turn.
Yeah, so I want to share something that I kind of learned in the past few months, more like an insight that I think is useful. Where like when we think about like building the streaming pipelines, sometimes we focus very much on the pipelines part. Like we provided the capabilities, we let people like deploying jobs and moving data around. But like one interesting observation here is like in the Web3 space, the data that we manage is public, open, shared data. And like ultimately, when we think about like the value that we are providing to the customers, we are not really trying to let customer deploying pipelines that are very similar to each other, but like running independently, like managed by their own. But more that we want to provide the value to the customer where they get the data, but we can also manage the data and ensure that the data is complete and correct. So it's kind of a paradigm shift from managing data pipelines to actually managing data for the users. Kind of going from like a stream processing engine to a streaming lakehouse. Recently, we did a lot of work with Iceberg. Like we do like read and write to Iceberg using Flink. And with Iceberg, we can do a lot of interesting stuff to ensure that our data is actually correct, it's valid, and we can draw insights from it as well. Like sometimes people think that, hey, we are working with blockchain data, the blockchain node is the source of truth. But in order to ensure that the data is actually correct with the node version upgrades and on those things, like it's not necessarily taken for granted that the data is correct. And we actually need to use more like techniques outside of stream processing to complement this and provide the full data experience for the users.
Our current pain point actually is because we are going to be running on a decentralized network, we can't expect people to have like really great networking. So crypto validators in particular like to keep costs quite low. So, they're not necessarily going to be paying for 10 gigabit Ethernet and stuff like that. So we have to spend some time making sure that what we do works on like 1 gigabit networking. And that's quite painful. So it's something that we're trying to address at the moment. That's our primary pain point.
Yeah, so okay, so actually we are we're running on time, right? All right. So yeah, actually today we actually discussed a lot about the streaming processing systems. Yeah, basically the streaming data infra, right? And we actually learned a lot about how the crypto companies or fintech companies can leverage stream processing technology to empower their business, right? So, all right. So Ivana, you want to say something?
I just like there is just like one question that is not being answered by Fahad, and it's for Yaroslav. Yeah, if we can just like take a look at that quickly, and then we can wrap up.
Do you want to read it? Do you want me to read it?
Super long, like kind of like that's it. Depending on upon distinctive challenges and requirements within the space, so what are the key features and capability that a stream processing tool like RisingWave and Flink must possess to become truly capable in this specialized domain?
Interesting. So James today, for example, talked a lot about decentralization, which I guess is more proper way to build in the space, right? But decentralization and streaming, it's really hard, right? As we heard today. So if you take like a more classical system like Flink or RisingWave, so it's the Web 2 one, I think what's really interesting here is state management, right? So if your streaming system performs any kind of join or aggregation, right? So you need to keep state. And you either do that in a windowed environment where you define a window of time, or a non-windowed, right? In a non-windowed, you will have to decide like how to manage state that's keep increasing, keep growing. That's typically not a very kind of long-term solution. So, and if you define any kind of window in the framework of choice, how do you define the watermarks, right? Because typically with Web2 data, we have like some clickstream data, some telemetry data. It's all timestamp based. You can definitely try to use timestamps as well, but I learned that actually maybe the better way to think about watermarks with blockchain data is the block number, right? It is the best watermark. It doesn't matter when it happened from time perspective. Maybe you ingested it, an hour ago, but if you can somehow leverage, like if you can somehow customize the way you generate watermarks in your streaming system and leverage a value that's not necessarily a timestamp, I think that's great. And that's something I try to, for example, do with Flink, but I quickly realized that in a lot of the layers in Flink code base, there's the simplest assumption that watermark value is always a timestamp. And you can just put like a random number in it. A lot of things will break. And yeah, I think it's a relatively small change, but if you do that, you can do a lot of very cool things, not just with blockchain, but with anything that's like monotonically increasing, like a logical type of timestamp. I don't know a lot of companies do that right now, specifically for like stream processing and watermarking, but yeah, that's just like one observation I wanted to share.
Okay, something for a roadmap. Okay, we have to wrap up this. Many thanks for joining us today. It was really like super insightful, and I hope to see you all soon. Like we'll have this accessible online, and we'll have some shorts that you can share. Yeah. So once again, thanks, and talk to you soon.
Thank you.
Well, thanks for having me.
Thank you. Yeah.
Ciao.
See you.